I think we are going live. We are live. Perfect. We are live. That's great. Let's see. I can see some attendees coming in. Welcome. Let's see. I can see everyone. Some attendees coming in. Welcome. Everyone. Some attendees coming in. Welcome. Apologies for the echo. Oh, sorted. Sorry.
Yeah, I was just about to tell you in case you didn't realize that that was happening.
Yeah, no. It's. I thought I closed that page, and so it was. I couldn't understand the source of the noise. Well, as people started flocking in, hopefully, it's a pleasure for me to welcome you to this new seasons of Astronomy in the City. Still in virtual format. We are working to resume our beloved live event soon, hopefully beginning of next year. So stay tuned, and in the usual channels, both our Twitter and Facebook accounts of the University of Birmingham Observatory, but also by joining the mailing list that you can find on the Astronomy in the City website to keep in touch with all the updates about future events. I see more attendees coming in. Welcome you all. It's a pleasure having you here tonight. We'll give a couple of minutes for additional participants to join before we start on the with the questions. I can see already some questions being typed, both on YouTube in particular. I want just to remember all the attendees that you can ask questions both on YouTube, on our live stream, underneath the video, the talks that you have just seen, but also here on Zoom. And we will try to read them all and try to respond to all your curiosity. There is no topic regarding the questions you might ask. We are here to sort of like try to reply to all your curiosity if possible. And in particular for that, I would like to thank the panelists that are here with us tonight, and I'll take the opportunity to introduce them all just now. So we have Matt. He's the current director of the observatory and the main speaker of the night. Just seen his nice presentation on supernovae. So in case you have any questions on that matter, please feel free to ask him. In no particular order, we have Simon Wooding from the AstroSoc, crucial contributors to this event. They always are very helpful in arranging and organizing Astronomy in the City. Simon is the outreach coordinator of AstroSoc and has been also the equipment coordinator of AstroSoc. So he has particular experience also when it comes to observing the night sky. So if you have any curiosity or questions about that, please feel free to ask. Then we have Sean. He's a senior lecturer at the University of Birmingham and head of year 1 in physics, and so more experience among us tonight, and he's particularly knowledgeable about well, stuff on slightly larger scale than supernovae. So we have galaxies and more distant universe. So in case you have any questions about that, again, please feel free to ask. And on the same kind of topic, we have also Dan. He works, he's a PhD student at the University of Birmingham. He works with galaxy clusters. And in case you joined last year's event where he gave a talk on lensing, this very fascinating property of, or phenomenon that you can observe in the universe. He's an expert on that. And so if you have any questions regarding this really massive galaxy clusters or lensing, again, please feel free to ask. I see also Cressida here with us, another PhD student at the University of Birmingham. I can see that she might have some technical problems, but she might be able still to type in case. And her topic in particular is the study of the evolution of galaxies and the interplay between galaxies, galaxy evolution and their location in the universe. So if you have any question on that, again, please feel free to ask. Finally, there is me, and I'm a postdoc at the University of Birmingham, and I work very closely with Sean, Dan, and Cressida, again, sort of on the large-scale structures of the universe and galaxy evolution. So very happy to reply any question on that topic as well. But again, we'll try to respond to any curiosity or question that you might have on sort of astronomy in general. And equally, if you have any curiosity regarding the astronomy curriculum at the University of Birmingham, so please feel free to ask. I think this would be, I babbled enough. And so I think this would be a good time to read the first question that I see from Alan. I will read it live and aloud, so then the panelists can chime in. Alan asks about what causes the universe to accelerate. There is no effect without cause, so why is it accelerating? Where does the energy come from? So it's a very, very, very good question to start the night. So if any of the panelists would like to chime in.
I mean, I will say something. I guess the problem with that, not the problem with the question, it's an excellent question, and it's something that basically all cosmologists are currently trying to figure out. We don't know what caused the universe to accelerate. I think it's something called dark energy, which is sort of a property. If it's a vacuum energy, it's sort of a property of the space, which to some extent means that that energy was already there and it has a repulsive force. And unlike, say, gravitational force, which pulls things together, it pushes them apart. So that's essentially what causes the acceleration. The last part of that question is very interesting, which is, where does the energy come from? The conservation laws in general, like energy conservation, which is kind of what this question is getting at, that energy has to come from somewhere, are really a result of symmetries in the universe. So there's something called Noether's theorem, which says that conservations are always related to symmetries. So there's something called conservation of momentum, and that's because the laws of the universe are the same whether you move it translationally in the universe, unspatially. The problem, and so energy conservation comes from the fact that laws of physics in theory are time invariant. They don't have any difference in time, except that's not really true in general relativity. The case is that they do become invariant, which is why energy isn't exactly conserved actually in our universe. So that idea of energy conservation sort of falls down in terms of general relativity. That may have been more detailed answer than you wanted, but that is the answer.
Great answer by Sean. And if there is any need for any additional clarification, Alan, please feel free to type in. Let me see if we have some additional questions coming in. I'm checking also YouTube pages. Don't see anything there currently. Again, please, to all the attendees, feel free to type any question or curiosity you might have, even if you think that the question might sound silly. There is no such thing, so we are more than happy to reply to any question. I have a curiosity myself. What's the weather currently in Birmingham? Is it observing. Would it be possible to observe tonight?
I don't think so. It was raining most of the day. It cleared up briefly in the afternoon. I was actually at the observatory when the sun came out, but by the time I was back in central Birmingham, it was raining again. So
it's meant to start raining in about 15 minutes according to the forecast. So probably
Standard
not.
astronomy in the city weather. Then that's good to hear.
Mm-hmm. It's meant to be good tomorrow, though. Actually, I think so. You never know.
There's been it's a debate among the more experienced in astronomy in the city to move the day either before or after, given that the record shows that Wednesday is the worst for weather on record, but it's for another day. But
But if you moved it, then that would become the worst day statistically, because that's how weather works. It's the universe messing with you.
We have a comment on that matter from Alan. He says that the sky is clear in Malta, and I can second that from Cyprus. It's perfect.
So, Matteo, while we're waiting for another question, I can add to the accelerating universe a little bit, just to make everything about supernovae again. The way we actually measure this expansion of the universe is
Great
by
segue. Thank you.
by observing these distant supernovae. So this was the Nobel Prize in 2011 was for this discovery that if you observe these type 1a supernovae that I mentioned in the talk, the explosions of white dwarfs, they basically all have the same peak brightness or close enough that you can work out the true brightness. So if you know how bright something appears to be and you know how bright it should be, then that tells you how far away it is. And from the spectrum, you can measure how fast it's moving away from you. So that lets you measure how fast the universe is expanding at different distances away from us. And that's actually how we know that the universe is accelerating faster and faster and faster over time by looking at these supernovae at different distances. So it always comes back to supernovae.
Great. This was, indeed very topical, and apologies for missing the cue. I was scrambling, looking around, and clearly missed an opportunity to question you. We have a question actually again on the expansion of the universe from Paul on the chat. I'll read it out loud. If the universe is indeed expanding, does every particle within it also expand in size at the same rate of expansion, or do the particles stay the same size? How can this be proved in either instances?
Ooh, I think the last part of that's almost the most interesting, because if everything was expanding, including the particles, I don't think we'd have any way to measure it. If you just increase the scale of everything in the universe, including us and our measuring sticks, we have no way to know. But in terms of what's going on in the universe, so you've got these two different things going on. This is sort of what Sean mentioned, that gravity's pulling everything together, and this dark energy or something that we don't really understand is pushing everything apart. So this pushing everything apart force works the same throughout the whole universe, but the gravity obviously depends on having a strong concentration of matter. So on small scales where the actual matter is, gravity tends to win. And so something like an atom or a person or a planet or whatever will sort of stay close together while the space in between things expands. So right now it's mostly galaxies expanding away from each other. Eventually in the very distant future, when this universe is expanded so much that everything's very far apart, then I think even the stuff within the galaxies will start to be overwhelmed, and gravity will lose out in the end, but we're still nowhere near the point where gravity starts to be defeated on the small scales. If anyone's got anything to add to that, Sean probably knows more about cosmology than I do, so maybe I got all that wrong.
No, that's good. That made sense. Yeah, it's good.
I mean, I guess
it is interesting, the question that you asked at the end about how would you prove if everything was changing, and that's, I think it's probably you can't rule that out, that everything is. I guess the thing to say is that we can say that the universe is expanding at a different rate from us, because we would have, that differential between our instruments and their instrument and the universe is getting such that the universe seems to be expanding. whether there's another overall expansion is very difficult. But also, you know, if you never notice, does it really matter? I don't know.
I just wanted to add to that and just say that, yeah, while it seems that space expands from every point, for example, if it was expanding from inside an object like a table, then the thing that was really stopping it from expanding is not just gravity, but also the electrostatic forces that hold like individual atoms together, which are typically a lot more stronger than gravity on these scales. So you'd never notice things flying apart due to the expansion of the universe because they're held together by these strong forces.
Thank you for the very complete reply from all of you. Let me check for additional questions. I don't think there are any yet.
So if there's no questions at the moment, maybe I could ask one to Matt that a curiosity I had about his talk. So Matt, you talked about the fact that you can observe remnants from supernovas that happened many thousands of years ago that were likely never observed. I was just wondering what other information you can kind of infer from those remnants. Like, can you tell what type of supernova it was and things like that?
Yeah, great question, Dan. Very often you can't tell what supernova it was. There's a few different ways that you can do this. So it depends a little bit on the age of the remnant. If the remnant's still pretty bright and it's got, you know, some of the images you can see clear kind of clumpy structure in different colors. The different colors of these images are very often based on different spectral lines that correspond to different atoms. And so if you can sort of see that this supernova produced a huge amount of iron, for example, then it's probably a type 1a supernova. Or if it's a huge amount of oxygen, it's more likely to be a core collapse supernova. So that's one thing that can help you. There's sometimes a more direct way to tell, which is you can get something called a light echo, where there's a sheet of dust or something that's some distance away from the supernova. And what happens is that the light that was emitted from the supernova at the time of the explosion actually reflects off this dust and comes back towards us. So there have been cases where we've been able to get the spectrum of the supernova at the time of its maximum brightness, hundreds of years after the supernova happened, because it reflected off some dust sheet to increase the time it took the light to get to us. So from that, we'd be able to actually classify these things spectroscopically the exact same way you would do with a new supernova that just exploded yesterday. So it's really exciting when that happens, because you can learn all kinds of stuff about it. You can measure the velocity at the time of the explosion and what the outer layers were made of, not just the innards. And then of course the final way you can kind of tell is by looking for a remnant in the center, so that the neutron star that was left behind it was a core collapse supernova.
Okay, yeah, thank you. And is it how far back is it possible to still see these things? Because obviously I'm assuming the light's fading fairly quickly.
Yeah, so the time scale that they stop being bright at is basically the time whenever this shock has gone so far out that all the supernova material has merged in with the sort of interstellar medium. And that typically takes something like 10,000 years before it's hard to identify as a supernova remnant anymore. So by that time, these things are, incredibly huge, hundreds of light years across. So at that point, it's barely a supernova remnant anymore, and more just a slight pocket of different density gas. But you don't see a strong shock front anymore that lets you know that it was a supernova remnant.
And has anyone looked for any remnants from superluminous supernovae, say in the LMC or SMC?
That's a good question. I don't think that anyone's done that search. It might be a little bit difficult to tell that it was superluminous, because if the main theory that I advanced in the talk, that it's a sort of hyperenergetic neutron star engine, this thing, it makes a supernova bright because it can turn all its rotational energy into electromagnetic energy quite quickly. But that means that the spin period of this thing slows down pretty quickly too. So after a few weeks, it's spinning more like a normal neutron star. So it'd be hard to tell looking at it, hundreds or thousands of years later, that it was born very, very energetic. Now, it might be that the supernova blast wave has also been accelerated, as well as the luminosity being increased. And in that case, you might see that it's a brighter radio source than a normal supernova remnant, because this shock more energy than most. But as far as I know, there's no examples of sort of anomalous supernova remnants that people have noticed. I might also not have thought to interpret them as superluminous supernova remnants.
Okay, yeah, cool. Thank you. Just curiosity.
Yeah, well, that's a good idea. I'm going to go have to look now and see what known supernova remnants are in the Magellanic Clouds.
Thank you very much for the debate. I don't see any additional question coming in from the participants. We have a message from Alan. He's going to look for meteors as advertised in our in the sky this month. So Astronomy in the City providing service once again. Enjoy, Alan. It's been great to have you here, and looking forward to have you here some more. I would like actually to take the cue from this, and in particular the talk given by Oscar from AstroSoc, to ask Simon if he would like to comment on future events that AstroSoc might provide during this semester, if there is anything he would like to share.
Yeah, so I've got a list of our events up here. Quite a few of them are student focused, obviously, so not that relevant to our audience here. There is going to be a T-Talk and Telescope on the 18th of November. I don't know who it is yet. I'm still trying to organize a speaker, but there will be somebody. And that's also open to the public. We have a separate mailing list for that. Feel free to look up our Facebook page or this YouTube channel that this is being streamed on. Also will have links to our other social media. And yeah, we've got a few things coming up next term as well, which dates aren't finalized for that, but there will be more things like this. And obviously, of course, future Astros in the city. That's the plural, I think. But yeah, no, if you want to know more about our upcoming events, message us on Facebook or comment on this YouTube channel and we'll get back to you.
Excellent, great, thank you very much. Again, thank you, especially AstroSoc, for arranging these events even in difficult circumstances. I think, given that there are no additional questions, both on YouTube and on the Zoom chat, it's about time to wrap this event up. Again, thank you all for the viewers. Thank you all for the attendees at the call and for the question being submitted. We will echo what Simon has said. Keep an eye on the usual channels for the promotion of additional events. So there will be one already confirmed on the 17th of November. You will receive reminders in due time. Which will still be virtual, but we are working to make sure that, or to try at least to have a full-on live event with the new year. So hopefully in February 2022, we will be back in the usual classic live form of Astro in the City. So with that being said, I would like to thank you all. Thank you also to all the panelists that joined us tonight. And well, I wish you all a good time and see you all soon.